Now that you learned about how the temperatures and the trends in them work, the same thing of course applies to any climate variable you can think of. It can be rainfall, which we worry about a lot other than temperature. It can be snowfall, it can be heat waves, it can be heavy rain, extreme rain, which we have defined elsewhere, and so on. So let's continue this idea. We already defined anomalies again, but just in the context of this section, which you may be jumping to and not listening to other sections. Then you still want to understand anomalies. I already said what that is. So basically, when you have changes that are away from the expected temperature or precipitation. So let's say you are 10 years old and you have seen last few years that on May 26th you expect a certain temperature where you are, certain weather, let's say with humidity, dryness, rainfall, snowfall, and so on. And this particular year, 2024, May 26, feels different to you. Maybe it's too hot, maybe it's too cold compared to what you expect, and so on. Those are called anomalies, and obviously there is a mathematical way to do this. You take many May 26s from the past, so you get data for that in various forms, and you average all May 26 weather from the past and say this is the average weather we would expect on May 26th. And if this particular May 26 in 2024 is different than the average we expect, then we say it is anomalous in some way. So here temperature, precipitation changes in Mumbai, temperature and precipitation changes in Mumbai. So they are doing monthly changes compared to the baseline. So I mentioned May 26th compared to other May 26s from the past, but you can do all of May compared to the Mays you have seen before. So then you would average all of months of May every year. So if you have temperatures every day, then you would average over May and say that's the May average for this year. Then you will do the same thing for many Mays in the past and then find an average May, and for that you use something called a baseline. What is a baseline? Basically, let's say you have data going from 1980 to 2010, and obviously if you're very young, most likely you are if you're listening to this, then this is from way before you were born. So you take all that past data. Just because you're young doesn't mean you cannot take the data from before you were born and do the average, right? So you can obviously do that and find the mean of those years, mean months, mean January, mean February, mean March, and so on. And you get a seasonal cycle, right? Winters are cooler depending on where you are. Spring begins to get warm, summer tends to get warmer, and then fall comes, and then the winter comes. So there is a cycle. The cycle is not necessarily the same every year, as we'll see. So the deviations every month from the expected average of that month during this baseline period, which is the mean of 1980 to 2010. There is no rule as to what the baseline should be. Typically you want it to be long enough. So this is 90, 2000, 30 years, as I mentioned before. Typically we take 30 years. If there is 100 years, sometimes you take an average of 100 years, and then there are other issues whether you should take the baseline for a very long period, because the baseline itself may be shifting, right? If each year is getting warmer, then the baseline itself is shifting, and so on. So if you don't understand, don't worry at this point. So we are looking at Mumbai, and we are looking at the 1980 to 2010 baseline, and then to find the anomaly from the baseline, you subtract. Let's say I'm in the month of May. Let's say May is still going on, so I take the temperature of April and subtract it, subtract the baseline from it. That gives me a difference of this year's April month from the baseline April month, or the average expected for 1980 to 2010, and we call it the anomaly. So was April of this year anomalously warm or cooler than a normal April, or the expected April, or the average April, or the baseline April? So you see that if you go from 1980 to 2020, or this goes to October 2021, thanks to the kind people of India Today group, and you see that there are many years which were warmer than the baseline. So obviously when you subtract and look at just the difference, then the mean of that is 0, right? If you don't understand, don't worry. So anomalies are positive or negative, which means you look at them around 0 just because you have removed the baseline. Okay, I hope it's clear. You take this April, you remove the baseline April, so you will only get a small number like 2 degrees or 1 degree or half a degree or so as the difference of this April from the baseline April, and that's what we are plotting here. So when it is red, then it is warmer than normal that particular month. So if you look at 1980 here, this each square here, each line here is a year, so you're going 80, 81, 82, 83 and so on to 90 and to 20, and then October 21, that's when this figure got made. You can extend this as the time keeps going. So when it is blue, it is cooler than normal. It was cooler than normal that month of that year compared to the baseline. So many months were warmer and many months were cooler. Can you see any difference here? Do you feel that when you come here, let's say past 2010, if you look at the number of blue here, number of blue months, these, remember, these each month is being plotted here for each year, you can see maybe that there are fewer blues here and more reds here compared to these times in the past. There were some reds and some blues, and doesn't seem like there were more blues or more reds before, but somehow it feels like, especially from 2010 onwards, maybe there are fewer and fewer blues and more reds. This tells you that each month of each year is now warmer than expected average or baseline of that month from the past. This tells you that maybe temperatures are getting warmer, which we already saw here. We saw the temperature of Mumbai averaged over all of Mumbai, and we saw that when we plot it, it is showing this red dashed line which is going up, which means year after year there is some warming. Each year may be warmer or cooler, just like here. So you still have warmer and cooler temperatures. It's just that number of cooler temperatures are decreasing. Okay, so can you do the same for rainfall? You see that you again take the baseline of these and compute every month's rainfall. Mumbai mostly gets its rain during June to September, so we ignore that for the moment and just plot every month of every year from 1980 again to October 2021, and you see that here now you have greenish colors for when rainfall for that month was above the expected baseline or normal or average, and when it is this drier color yellowish, then it was less than expected, right? Does it again feel that there were maybe one or more of the colors happening here compared to here? That's not so obvious, even though you can imagine that maybe there are fewer yellowish years or months here than here. Okay, but again you will have to do rainfall, plot rainfall like this and see if there is a trend, if there is a change. We haven't done that, so just remember that they are not the same. It may be more obvious here that there are fewer blues than before and more reds than before, but that may not be that obvious. So you have to see whether rainfall is, just because temperature is warming doesn't mean rainfall will decrease or increase. It depends on many other things like winds. Remember, Mumbai rain is associated with southwesterly winds, which we discussed before, not in this section, but you can go back and look at it. So winds may do something else. Temperature may be warming, which, warm atmosphere holds more moisture, it's thirstier, and there is an Arabian Sea sitting right next to Mumbai. So maybe more moisture is coming in and maybe more rainfall is falling when it warms. So all these things are complicated. Similarly, in Delhi, you can see that it's not so obvious that the number of blues and reds are changing. So as we said before, we said here that is Delhi getting cooler? Is Mumbai getting warmer? There is a question mark here. So you see that Delhi temperature doesn't have a very strong upward slope like Mumbai or Chennai here. So similarly, rainfall, so you can see that Delhi has maybe more blues than, or the reds are not as high here. Remember, these are numbers, temperature anomalies, which means warmer than normal by 4 degrees or cooler than normal by 4 degrees and so on. So you can see that there are not as many warm years as they were here. Let's say many years it crossed 4 degrees, it crossed 3 degrees, it crossed 1 degree and so on. Maybe they are not crossing such warm temperatures anymore, but maybe the cool temperatures are also not as cold anymore. So is Delhi getting less warm and less cold as well, and overall getting cooler? That's the question. And here again, if you look at rainfall, you see that again you don't see a very big difference. Maybe there were sharper increases in some months before and sharper decreases, but maybe now the jumps around zero, whether it's excess rainfall or deficit rainfall, is not as large as before. Is this just a descriptive thing that I'm talking about? There's a lot of dynamics before, which physics behind it and so on, which we will not discuss. But what you want to take out of this, the main message is that just because we are having global warming, we'll see later again that it doesn't mean every place in the world is warming. We'll see that the Arctic is warming more and India is not warming as much, or in some places it may be even cooling. But when you average over all the globe, there will be global warming because we are increasing greenhouse gases and we are trapping some of the thermal energy that should go out. It's like having a blanket on. You feel warm with the blanket, and if it's too hot and you wear a blanket, it'll get hot, so you will want to take off the blanket. So that's what is happening. The greenhouse effect of the earth is very useful. It has given us certain temperature which is not as hot as Venus or not as cold as Mars, and now we are trapping more and more of the energy going to space, which means we are making the blanket thicker and thicker. So now we are getting hotter and hotter. Okay, so global warming is happening because we are keeping more energy, but global warming doesn't mean everywhere it will warm. It will warm in some places, it will cool in some places, and so on. Okay, so we'll come back and move forward to the second chapter of this book, which is called, what is it called? Let's see. It is called Things Are Heating Up. So we'll start discussing how climate change is happening. Again, this is a simple book. It's meant for kids. So if you're older in grade 10, 11, 12 and you feel this is too simple, there are podcasts I have on my channel which are advanced. If you feel those are too advanced, you just send me questions saying, I understood this part, but I want to understand more of this, and then I will answer the questions. Okay, so see you next in the next chapter, talking about things heating up and what evidence we have for that. Okay, so see you in the next podcast.